Hey everybody, today is August 19th and this lecture is about describing quantitative data. We're going to focus on dot plots and stem plots. So first, types of graphs are there for quantitative data? We've got dot plots, look something like this. Stem plots, look something like this with numbers. Box plots, which look something like this. And then histograms, which look a lot like bar charts. Differences for quantitative data, we call them histograms. Bar charts are reserved for categorical data, and histograms, the bars touch, and in bar graphs, the bars do not touch. All right, so a little bit about describing. So when I use the word describe and AP statistics use the word describe, they don't mean just generally. It means something very specific and you have to do kind of a lot. There's actually 4 things we're going to focus on. We're going to use the acronym SOX to sort of remember the 4 things to do. So first, you're going to describe the shape. The shape would kind of draw like an idealized shape, and we'll use words like unimodal, which means one peak or one hump, symmetric, which means it's kind of same on both sides, skewed to one side or the other. Uniform is the same height, and using plain language is fine. I should have set up here with unimodal that it could be unimodal or bimodal. Unimodal is 1 peak, bimodal is 2 peaks. And then if there's any gaps or clusters of data, you'll note those too. Outliers. The outliers are extreme values. And you'll make a note of any possible outliers and call them possible unless you actually calculate the fence values. So just if you see any really high or really low values that are away from the rest of the data, you can note them as a possible outlier. Center, we have a few specific measures, the center is essential tendency. We have 2 different ways to calculate that, mean or median. It's best if you can calculate it. If you don't calculate it, you should be using the word approximate center. And then spread describes how far apart the data values are. We have 3 different measures. Today we're going to talk about the easiest one to understand, which is just range. Range is just how far apart the highest and the lowest value are. So the maximum value minus the minimum value. Later on we'll talk about standard deviation and IQR. So here's an example of a dot plot. You can see it's got a horizontal scale with numbers. It's labeled number of matches per box. That's our variable we're measuring. The individuals are the boxes. So this number of boxes, that's a count or a frequency. So in this, if I count up these dots, there's 20 total dots. And I can see here that there was 1 box of matches that had 45 matches, 2 boxes had 47, 1 box had 48, 4 had 49, etc. All right, and on to the description of a dot plot. Here, the shape, the distribution of the matches is slightly skewed to the left, which means there is a tail to the left. Skew skew means the tail. Sometimes students get confused and they think it means like the peak, but skew is the tail. Outliers, I see here this low number, and I noted as a possible low outlier box that had 45 matches. And we say possible unless we do a calculation. Center, the median number of matches is 50 matches. And I did that by counting to the middle value. So there's 20 boxes, the middle will happen between the 10th and 11th. So when I count both the 10th and 11th box of matches, they have 50 matches. And the spread, the range of matches is 7 matches. And I just subtracted. The max is 52 minus the min 45 is 7. All right, here's an example of a histogram. And so a histogram, how it's organized is you can see the scale, and these are ranges. So like this first bin right here, that means that in this bin, these are trees that they could be equal to 60, but less than 65. So the lower boundary is included and it does not include the upper bound. And so in this here, this frequency is a fancy word for count. And if I look at that vertical scale, that means that there were 3 cherry trees that were 60 feet or taller, but less than 65. So in between could be 60, but then less than 65. And if I put in the frequencies for the others, here's another example where here there was 8 cherry trees that were at least 70 feet, but less than 75. And if I was to add up the total cherry trees, if I added all of these frequencies, I would get 31 cherry trees. All right, let's look at an example description of a histogram. Here, the distribution of cherry trees is roughly symmetric. And it's not exactly symmetric. It's better to just not overanalyze the small differences that happen because variation is expected in samples. You kind of like look at it with squinted eyes and sort of like approximate shape, not exact. I don't see any outliers. There's no cherry trees that are way off, like super tall or super short. And we would say apparent unless I calculate. So center, the median height is between 70 and 80 feet. And I did that. If I add those frequencies, so there's 31 cherry trees in the total. So if I kind of add the frequencies, 3 plus 3 is 6, plus 8 is 14. And then when I add this 10, I'm going to get to 24. So I know that the 16th cherry tree happens in this bin. But I can't know the exact value of the median. I just know it's between 75 and 80. And then the range is approximately 30. I can't know the exact because I don't know what the shortest tree is. Maybe it's 60, maybe it's 61, maybe it's 64. I don't know. And the same with the max. I know that it's less than 90, but maybe it's 89, maybe it's 86. I don't know. All right, so here's some pros and cons about dot plots and histograms. So for the histogram, some of the pros, it's easy to see shape and it's good for large data sets. Some cons are that it's hard to make by hand. It's kind of a pain. You have to kind of like tally up put them in bins and arrange them, and it's a pain. And you can't see the actual data values, only the summary. So histograms, if you have a calculator or some technology to help you make the histogram, that's not hard. We'll be doing that really mostly. They're hard to make by hand. Dot plots, they're really easy to make by hand, just like you can make them quick and dirty, and you can see all the exact data values. A con is that it's very hard to use for large data sets because that gets tiresome with all those dots. And one thing I forgot to mention and put on there, I think I'll add this on the slideshow, don't forget context when you're talking about data. Data always has a context. It's always in real life. So make sure in your descriptions that you use context. I'll emphasize that in class next time. So for tonight, go ahead and read and take notes on pages 27 to 34. All right, have a great day and I'll see you guys soon.